to talk about how you solve equations and inequalities that have the absolute values involved. What you need to understand is that when you have the absolute value and you get what's in there to be one number, the answer is real simple. Write down this number with no sign, and you'll be correct. That is the absolute value of -3 is 3. And by the way, this is read as the absolute value of whatever you see in there. And you say -3. The absolute value of -3. Just like 2 plus 4 was a command to add, absolute value is a command to say what's in here without any sign. Don't put down a sign. Put down a sign with 50-50 chance of being wrong. Of course, if you wrote down +3, you'd be correct as well. But don't put down any sign. The absolute value of -2/3, just write down this number without a sign. The absolute value of 7/11, just write this number down without a sign. Even if it had a sign, it was a positive sign, it would still be 7/11. Just write down the number without a sign. The absolute value of any number is that number without a sign. Just don't write down the sign. That's all it means. It amazes me that so many people, students are confused about how you take the absolute value. They'll tell me the absolute value is 3, is -3, the absolute value of -4, they'll say it's -4. No, you never ever get a sign when you take the absolute value. You don't get a sign. Now, we know that this is 4. We know that's 4. That is, what I just put the circle around is 4. Somebody puts a negative in front, then it's -4. Oh, but absolute values never have a negative, you say. Absolutely. This is 4. This is 4. The absolute value of -4 is 4. I didn't write down a negative for that part. Not my fault somebody put a negative in front of it. I'm not saying just because you have absolute values you should never write negatives. I mean, that's not true. I mean, the absolute value of 8 minus the absolute value of 10. Well, this is 8 and this is 10. You subtract, you get -2. Even if that was the absolute value of -10. What I'm saying is the absolute value of this will not have a negative sign. Minus the absolute value of this will not have a negative sign. And 8 minus 10 is -2. So let me tell you what the absolute value of something equals, and you tell me what can go between the absolute value bars. What can go in between these bars if I tell you the answer is 7? Now, what you should ask yourself is very clearly, which numbers or numbers, if any? There might be one number, there might be more than one number, there might be no number. So that when you ignore the sign, you get 7. And the answer is positive or -7. If I ignore the signs of either of those numbers, bingo, I get 7. Why am I ignoring the signs? Oh, yeah. The absolute value bars tell me ignore the signs. The absolute value of what will give you 37. What numbers can I plug in there? So if I ignore the signs, I get 37. The answer is plus or minus 37. If I tell you that, if I ask you the absolute value of what number or numbers, if any, give me 0. Now, you might want to say plus or minus 0, which is fine, but both of those are 0. There's only one number that can go in between the bars. So there are cases where we got 2 numbers in the bars. Here we got 1 number, only the absolute value of 0 is 0. The absolute value of what number or numbers, if any, give you -83. The answer is nothing. Because no matter what number no matter what numbers you put in there, if you ignore the sign, you won't get a negative number. Because when you ignore the sign, either you get 0 or you get positive. Nothing. Absolutely nothing. So, if I called what goes in the bar as x, I say the absolute value of x is 7. Well, ignore what that is for a moment. What can go in there? Well, we just did that problem. Plus or minus 7. So, x can be plus or minus 7. If I told you the absolute value of x plus 2 is 37. Well, I know what can go in there. We just did it. Plus or minus 37. Now, of course, I won't let x be 37 because 37 plus 2 is not one of those two numbers I said can go in there. I'm going to say what's in there. It must be plus or minus 37. Either x plus 2 is 37, which of course means x is 35. You should know what plus 2 is 37. It's 35. Or x plus 2 is, let me write it, or x plus 2 is negative 37. Some number, when you add 2 to it, you get negative 37. Negative 38, negative 39. That number we now know. It's negative 39. And we called it x. If I tell you the absolute value of x minus 4 is 0. Well, the only numbers that can go in there is 0. That tells me x minus 4 is 0. And if you subtract two numbers and you get 0, you write down those two numbers or two expressions, and you put two horizontal lines between them. If one thing minus another thing is 0, then the two things are equal. X and 4 are equal. If I tell you the absolute value of x plus 11 is negative 83, you tell me no solution. Because there's nothing for x plus 11 to equal. Because x plus 11, no matter what x is, you pick random numbers for x's, and you add 11. You'll either get a negative number, or the number 0, or you get a positive number. When you take the absolute value of a negative number, you won't get negative 83. Take the absolute value of 0, you won't get negative 83. If you take the absolute value of a positive number, you won't get negative 83. You can take the absolute value of absolutely nothing and get a negative number. When we talk about inequalities, I'll change the way I just define absolute values. I'll talk about distance. But for right now, we don't have to worry about distances. And if I tell you the absolute value of what's in here is 5, well then you should know what's in there equals 5, or what's in between the bars equals negative 5. And if I tell you it's x minus 4 over 3, well then you should tell me what's in there is either equal to 5, or what's in between their absolute value bars equals negative 5. It doesn't matter what this is. It matters what can go in between the bars. 5 or negative 5. 3 times 5 is 15. That equals the numerator. Some number minus 4 is 15. Think about it. What number take away 4? How much money did you have? So when you spend $4, you have 15 left. Well, you have this 15 in your hands. You know where the 4 is you just gave away. Oh, I had the 15 plus the 4. I had 19. 3 times negative 5 equals the numerator. 3 times negative 5 is negative 15. Some number take away 4 is negative 15. You can do it. Here's some number. You take away 4. 1, 2, 3, 4, and you get negative 15. Now, you have to know that zero's here. That way you won't go negative 16, negative 17, negative 18, negative 19. Because if you did, I'm just going to ask you, when are you going to get to 0? It's negative 15, negative 14, negative 13, negative 12, negative 11. X is negative 11. But I thought absolute values cannot have negatives. It didn't. Absolute value was always 5. You can plug in 19. 19 minus 4 is 15. 15 divided by 3 is 5. And yep, the absolute value of 5 is 5. Negative 11. Negative 11 minus 4 more is negative 15. Negative 15 divided by 3 is 5. But we want the absolute value of that, which is 5, just what we wanted. Okay, it doesn't matter what's inside the brackets, inside the bars. What matters is what number or numbers, if any, you can put between those bars. And when you figure out what you can put between the bars, then you let what's inside the bars equal what it can be. You have the absolute value of x minus 7 plus 2 equals 5. It's this mess plus 2 equals 5. You should say, that's 3. 3 plus 2 is 5. It amazes me how teachers will insult students and not motivate them to think at all. Teachers out there, that they tell them to take away 2. People know that 3 plus 2 is 5. So the absolute value part must equal 3. This must be 3. After all, if I erased it, what goes in that circle? 3. 3. So whatever in the circle, odd looking, simple looking, strange looking, it equals 3. So the absolute value of what's in here is 3. What numbers, if any, if I ignore their signs, give me 3? The answer is 3 or negative 3. So what inside those brackets either equals 3 or they equal negative 3. What take away 7 is 3? 10. 10 minus 7 is 3. The x is 10. What take away 7 is negative 3? 4. 4. And you can work it out. Here's some number, x. Take away 7. 1, 2, 3, 4, 5, 6, 7. I end up at negative 3. Negative 2, negative 1, 0, 1, 2, 3, 4. And you can add 7 to both sides to find. That was a harder one. X is 4. X is equal to 10, or x is equal to 4. And the check is real easy. Let's check 10. 10 minus 7 is 3. The absolute value of 3 is 3. Yep. Plus 2 is 5. Let's check 4. 4 minus 7 is negative 3. But the absolute value of negative 3 is 3. Plus 2, yeah, 5. 3 plus 2 is 5. Now let's just do this one. So you have 2x plus 1 plus 7 is equal to 5. Well, this will have to be negative. Negative 2 plus 7 is 5. You can take away 7. And the right side is negative 2. And the absolute value is negative 2. Absolute value of 2x plus 1 is negative 2. the problem is that there's no numbers to put in there to get negative 2. There's nothing that can go in there. That's a symbol for the empty set. No solution. This problem has no solution. There's nothing that I could let 2x plus 1 be. Doesn't matter what it is, once we take the absolute value of it, it won't be negative 2, but it has to be. Okay. Now we're going to go on to inequalities involving absolute values. Let me give you a definition. Whenever you see this means the distance between A and B. A and B. I should say equals. It equals the distance between A and B. Now, if you live here, I meant to call it H for home. If you live here and your school is over here, and somebody asks you how far is it from your home to school, and you tell them 8 miles, I doubt very much so that if somebody said to you, how far is it from your school to your home, then you would say negative 8 miles. If somebody asks you, how far is it from here to the grocery store? How far is it from where you work to the store? You never, ever say, oh, it's negative 2 miles. You always say 2 miles. Whether you're going there or coming back from there, it's 2 miles. Whether you go from H to S or from S to H, assuming it's the same route, it's 8 miles, not negative. Distance is never negative. Distance. It is never negative. Distance is never negative. So, suppose I give you this. Now what you need to do is know how to read this in English. Well, I just taught you what this means. The distance between x and 4. The distance between x and 4 is greater than 3. The distance between x and 4 is bigger than 3. Well, here is 4. Now, where can I put x? Can I put x here or here? I mean, there are many, many, many places I can put x. But how do I decide if I can put it here? Well, the answer is real simple. If the distance between x and 4 is bigger than 3. 1, 2, 3. If I go bigger than 3, x can be here. 5, 6, 7. If I go to the right of 7, then no matter which value I pick for x, wouldn't the distance between all these x's and 4 be more than 3, greater than 3? I can also go 3 to the left. 1, 2, 3. But greater. I can go greater than 3 to the left. 3, 2, 1. These can be x's. Since it didn't say greater than or equal to, I really can't be 1, nor can I be 7. X must be more than 3 units away from 4. The distance between x and 4 is greater. I left out a key word, sorry. Greater than 3. So the answer is x can be bigger than 7, or these numbers are all less than 1, or x can be less than 1. That is the answer. Your teacher is going to teach you some boring, dry rules where you just go home and memorize, and you just have absolutely no understanding. You know, why bother even going home? I mean, this is my attitude. Why go home and study if it's just pure memorization? I surely wouldn't. Should understand it. If I tell you that, if I tell you this, less than or equal to 5. This means the distance between, there must be a minus in between, the distance between x and 2. The distance between x and 2 is less than or equal to 5. The distance between x and 2 is less than or equal to 5. Well, here's 2. So the question is, where can x be? Well, the distance between x and 2 have to be less than 5. 1, 2, 3, 4, 5. Less than or equal to. Well, if you add 2 and you add 5, you're at 7. That means it has to be 7 or less, up to 2. But you know what? X can be on the other side, as long as it's not more than 5 away. 1, 2, 3, 4, 5. 2 minus 5 is negative 3. If you don't like that, 1, 0, negative 1, negative 2. Like I said, negative 3. X can be anywhere up to 5 away from 2. Either to the left or to the right. This here is one region. This here is one region. So I can just write one inequality. In the last problem, I wrote 2 inequalities, except I erased it. I wrote 2 inequalities. Like, I think I said x was less than 1, or x was bigger than 8. Here, that is, I had something like this. It was to the left of negative 1 and say to the right of 8. That means x is less than negative 1, or x is bigger than 8. 2 pieces, 2 inequalities. Here's one, or, and here's the other. 2 pieces. Here I have one piece. X is in between negative 3 and positive 7. No matter what x I pick between negative 3 and 7, the distance between that x and 2 will be less than or equal to 5. Just think distance. Book that I learned absolute value inequalities from, they mentioned how we understood distances when we were really, really young. There were 2, when you're a little baby and you're crawling, and you can only crawl, and there's 2 balls, they're both the same. You knew to crawl to their ball that were closer to you. It was less work. Now, okay, let's do this problem. 2x minus 5 is greater than or equal to 3. The distance between 2x and 5 is more than 3. So here's 5. I go more than 3 to the right, more than or equal to. That is, this can be 2x. It can be greater than or equal to 8. Or you can go more than 3 units to the left. 1, 2, 3, and then more. 4, 3, 2. So 2x must be less than or equal to 2. Just divide both sides by 2 on both inequalities. X is less than 2, x is bigger than 4. And there's your answer. X can be less than or equal to 1, or x can be bigger than or equal to 4. I mean, let's make sure this is working. Pick any number bigger than 4, bigger than or equal to 4. Try 7. 2 times x minus 5. Is it really bigger than 3? Well, 14 minus 5 is 9. The absolute value of 9 is 3. Yep, that's bigger than or equal to 3. Take a number less than or equal to 1. 0. I was looking at the 2 in the formula. 2 times x minus 5. Well, this is 0 minus 5, which is negative 5. The absolute value is 5. And wow, that's bigger than 3. Pick a number in between that we're saying is not an answer, like 4. 2 times 4 is 8 minus 5. Oh, I don't know. I know. I'm looking at x cannot be, I don't want a number 4 or more or 1 or less. Let's try 2. 2 is not less than 1, and 2 is clearly not bigger than 4. So you get 2 minus 5. 2. So you get 4 minus 5, which is negative 1, and the absolute value is 1. And that is not bigger than 3. Okay, that is not bigger than 3. Distance. Well, you may say, but what if you have x plus 2 is bigger than 6? Well, you're supposed to know that, like if somebody asked you to calculate 5 minus a negative 7, you would say change and change. But you know what? You can change and change again. You can change both of them. For example, if your addition button stops working on your calculator, that doesn't mean you can't use your calculator until you get another one. Do subtraction. Change addition to subtraction. Change the sign of the second number. And your calculator will give you 12. That is, you should change this to subtraction and change that understood positive sign to a negative. So now it's the distance between x and negative 2. Here is negative 2. The distance between x and negative 2 is bigger than 6. So you go more than 6 to the right, but not equal to 6. And you go more than 6 to the left, and that's what x can be. This is 4, negative 2 plus 6 is 4, and negative 2 minus 6 is negative 8. So, x can be greater than 4, or x can be less than negative 8. Now, if instead it said 3x, well then fine. Then 3x can be less than negative 8. 3x can be bigger than 4. That's the main difference if you have other than x. But there is one more line. I don't want to know about what 3x's can be. I want to know what x can be. Divide both sides by 3. X is smaller than negative 8/3, or x is bigger than 4/3. Now, sometimes they want you to write this in interval notation or on a number line. This here is what name to call this answer, but here's the answer. Now, if you were asked to draw a number line for the solution, I like to put 0 down. Well, here is 4/3. You can be bigger than. X can be bigger than, but not equal to. Hence an open circle. If it could have equaled 4/3, would have filled in the circle. Or x can be less than negative 8/3. Here's negative 8/3. Now, as long as x comes first, second. If x is first, the arrow tells you which way to go. The arrow points to the left. X was first, the arrow points to the right. I went to the right. There's a number line solution. Sometimes they want you to write the answer in set builder notation. This really drives students crazy, but it's simple. As long as you can get this answer, as long as you can get that answer, the set builder notation is very simple. It's just cosmetic things that you change. You put brackets around it, and since the unknown is x, you write x with a bar, and that's it. This piece is exactly what many of you can get fairly easily. Just put this, and this, and this, and that. And you will have the answer in set builder notation. Now, what if I tell you that the absolute value of A is equal to the absolute value of B? What can you tell me about the A's and the B's? Well, first thing you should say, well, if you ignore the sign of A and you ignore the sign of B, then they're equal. Well, if they're both positive, if A and B are both positive, then A can equal B. If A is negative, change the sign, it becomes positive. And if B is also positive, well then negative A equals B. If they're both negative, then negative A is equal to negative B. If A is positive, but B is negative, if B is negative, this is negative, you put a minus sign in front of it, it becomes positive. Okay, now if you think about it, this one is the same as this equation. Because you just multiply both sides by -1 and you get the same. And this last equation is the same as the second. Because if you multiply both by -1, they're the same. That is either the two things inside the brackets are equal or they differ by a sign. Either they're equal or they differ by a sign. One is 3, the other is -3. Or they're both the same. Both 3's or both -3. So here's the theorem. The absolute value of A equals B. Then A is equal to B. Or A is equal to -B. So if I tell you the absolute value of 2x plus 3 is equal to the absolute value of 3x minus 4. And I say solve this. Well, you can say that they're equal to one another. Bring the x's to the right side. The right side has more x's. And bring the numbers to the left side. Left and right of the equal sign. The left side has 7, the right side has x. That's one answer. But they didn't both have to be equal. They could have differed by a sign. Just 3x minus 4 and the 2x plus 3 could have differed by a sign. A lot of students would say, oh, this is so simple. Just put a minus in front. No, you only took away part of the 2x plus 3. You have to take away the whole thing. 3x minus 4 is equal to negative 2x minus 3. Left side has more x's. So bring all the x's to the left side. That is, get rid of the x's on the right side by adding 2 x's. Bring all the numbers to the right side then. Add 4. There's no numbers on the left side. And now you get that 5x's is 1. Divide by 5, divide by 5, do the space, I'm over here. X is 1/5. Those are the two answers. X can be 7 or 1/5. Let's check 7. 2 times 7 is 14, plus 3 is 17. The absolute value of 17 is 17. 3 times 7 is 21. Take away 4, 17. The absolute value of 17 is 17. And of course, they're equal. You plugged in 1/5, and I didn't make a silly error, you will get the same results. You won't get 17 equals 17, but you'll get one number equals itself. 3 equals 3. 4 over 11 equals 4 over 11. Absolute value of one thing equals another. Either the two things are equal or they differ by a sign. And all I'm saying is the absolute value of A is equal to the absolute value of Y. Well, it doesn't matter what the sign is, because when I take the absolute value of this, I look just at that. I don't look at the signs. So that is why it either equal, either A is equal to positive A or A is equal to negative A. What's inside the two brackets are equal or they differ by that sign. Okay, that completes this section.